This video is for Lesson 8-7. Students will solve one-step linear inequalities. Please get your materials ready and open your textbook to page 636. Before we get into today's lessons, let's do a quick review back from Chapter 7, where we solved one-step equations. So remember, our goal is always to get the variable by itself. So here I have x plus 3 is equal to 4. So to get to x by itself, I'm going to subtract 3 from both sides of the equation, and we get x is equal to 1. Over here, if we had x minus 3 equals 4, to get the x alone, we would add 3 using the inverse operation of addition. The 3's would cancel, leaving us with x is equal to 7. On this next one, we have 3 times x is equal to 6. So we have multiplication in here, so to get rid of it, we're going to divide by 3 on both sides. 3 divided by 3 is 1, and 1 times x is x. 6 divided by 3 then is 2. Over here, when we had division, the x and the 4 were joined by division, we multiplied by 4 on both sides, and the 4 is canceled, leaving the x by itself, and 10 times 4 is 40. Well, today our lesson is going to involve inequalities, meaning instead of seeing equal signs on either side, we're going to be seeing that greater than, less than or equal to, or greater than or equal to signs in the middle. And what's great for us is that the same rules will apply. So, when we're using addition and subtraction properties to solve inequalities, we just have to remember that if you add or subtract the same number from the left side, you have to subtract it also from the right side, and then the inequality stays true. So we have 5 is less than 9, which is an inequality because 5 and 9 are not equal to each other. Remember, in means not. So if I decided to add 4 to the left side, I would have to add 4 to the right side. So then 5 plus 4 is 9, which is less than 9 plus 4, or 13. And that's a true statement. 9 is smaller than 13. And the same is true for subtraction. If I subtract 3 from the left, I have to subtract 3 from the right. And 11 minus 3 is 8, which is still larger than the 6 minus the 3, or 3. So these properties are also true for the less than or equal to and greater than and equal to signs. So let's take a look at this one. It says solve x plus 7 is greater than or equal to 10. Then graph the solution on the number line. So we have two parts here. First we have to solve the inequality, and then we have to do our graphing. And this is just taking out our stuff from Chapter 7 over here on 1 and combining it to what we did here on Lesson 8-6. So if we start off here, we need to get the variable all by itself. So the 7 is attached to the x with addition. So we're going to subtract 7 from the left, which means we have to then subtract 7 from the right. So the 7's will cancel, leaving us with x. And now instead of bringing down the equal sign, we just bring the inequality sign. We don't make any changes. We don't flip-flop it. We just leave it as it is. And then 10 minus 7 is 3. So our answer is x is greater than or equal to 3. Now they would like us to do the second part where they're asking us to graph it on the number line. So x is greater than or less than 3. Remember, we used a closed circle for greater than or equal to, as well as the less than or equal to sign. Remember, it's an open dot for greater than or less than signs. So because we have the equal sign down here, we have a dot here at the 3, because our answer can be actually 3. Then we have to pick values that are greater than 3. So I know 4 is greater than 3, 10 is greater than 3. I can check the other side. 2 is less than 3, so that doesn't work. So I take it up and put my arrow to the right. Try another one. Solve x minus 3 is less than 9. And then we're going to graph the solution. So the 3 is attached to the x with subtraction, so we'll add 3 on the left and add 3 to the right. The 3's then cancel, and so all we're left with is our x is less than 9 plus 3 is 12. So x is less than 12. So we're going to use an open circle this time on the 12 because we cannot have the answer equal 12. So now we need to find numbers that are less than 12. So I know 11 is less than 12 and 8 is also less than 12. I can check the other side. 13 is larger, so that doesn't work. So my arrow is going to come up and go to the left. So let's try a couple here. First I'm going to start off with I have the n and the 2 are joined together with addition, so I'll subtract 2 from the left. Therefore, I'll have to subtract 2 from the right. The 2's then will cancel, leaving me with n is less than or equal to 3. So I go to the 3, and because I have that equal on the bottom, I'm going to make a solid dot. And now I need to find values that are less than 3. So 2 is less than 3, 0 is less than 3. I know 4 is greater, so that won't work. So I put my arrow up and over. Let's try the next one. The y is attached to the 3 with subtraction, so we're going to add 3 on the left and add 3 on the right. So the 3's cancel, leaving me with y is greater than 12, because 9 plus 3 is 12. So when I go to the 12, because I don't have the equal sign, I'm going to leave it as an open dot. And now I need to find two numbers that are larger than 12. So 13 is larger than 12, so is 15. So now I can take my arrow up and over the 13 and the 15. The same properties hold true for multiplication and division. Whatever I do to the left, I have to do to the right. So 5 is less than 10. So if I took 5 times 2, I get 10. And if I took 10 times 2, I get 20. And again, 10 is still less than 20. The same for division. If I divide 16 by 2, I get 8. And if I take 12 divided by 2, I get 6. And 8 is still larger than 6. And of course, this is also true for the greater than and or equal to or less than or equal to signs as well. So here we have 5x is less than or equal to 45. And they want us to solve and graph this on a number line. So the 5 and the x were joined with multiplication, so we divide by 5 on both sides. The 5's cancel, and we have the x is less than or equal to 9, because 45 divided by 5 is 9. So going over here, I have the equal sign at the bottom, so I'll make my dot right on the 9. And then I'm going to find values that are less than 9. So 8 is less than 9, as well as 6. So my arrow goes up and to the left. Now over here, x divided by 8. So I'm going to use multiplication to get rid of the 8. Now normally we put it over here on this side, but this is fine to have it on this side as well. But my 8's will cancel, and then we'll have x is greater than 24, because 8 times 3 is 24. So I start at 24 with an open circle this time, because I don't see the equal sign. And so 25 is greater than 24, so is 27. So my arrow is going to go up and to the right. Let's try one here. We have 10 times x, so we're going to get rid of it with division. I'll divide by 10. The 10's cancel, so I have x is less than 8. So going to my number line, I go to the 8, and I'm going to put an open circle because it doesn't have the equal sign underneath it. And now I need to find values that are x has to be less than the 8. So 7 is less than 8, 6 is less than 8. So my arrow is going to go up and to the left. On the next one, we have division. So I'm going to rewrite it so I have room to show my work. So we'll start off by multiplying both sides by 6. So the 6's cancel, leaving me with x is greater than or equal to 42. So I'm going to make a solid dot on the 42. And I know that 43 is greater than 42 as well as 45. So my arrow is going to go up and to the right. So of course we have one more with a story problem. Laverne is making bags of party favors for each of her 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. So we have 7 people coming, and we're going to have to multiply that by the cost of each bag. And she doesn't want it to be more than 42, but she can spend 42. So I'll start with the equal sign, and we definitely want the 7 times c to be less than that. So to solve it, I'm going to go ahead and take and divide by 7 on both sides because the 7 and the c are joined with multiplication. The 7's will cancel, leaving c is less than or equal to 6. So she can spend a maximum of $6 on each of her party bags. So the next thing it said, solve. Oh, and this time it does not say to graph it, but if we did, I'd make a number line, and I'd have the 6 in the middle, and I put a couple numbers on each side, and we could graph this and saying that it could be equal to 6, so I can put a dot, and it has to be less than, so we could spend $5 or $4, and our arrow would go to the left. So if you have questions, come and find me, or rewatch the video and try again, but give your homework practice a try, and come and see me if you need help. Good luck.